Visual effects has been on my radar for quite a while now. It's something that I've always wanted to learn and sort of give a go and try and up level my games in a visual aspect and try and make everything look a lot cooler. So in this video I'm going to go over what visual effects is as a whole. I'll be mainly talking about visual effects in games, and I'll be going over the visual effects graph in Unity. And I'm also going to go over why you should use visual effects and consider learning it yourself, how to get as much knowledge in as possible in a short period of time. So, what is visual effects? Visual effects is built up of 4 pillars: colour, shape, contrast and time. After researching these pillars, I found they are a great way to structure your visual effects and sort of great to follow when you're making visual effects for games. So, starting with colour. The obvious one is obviously red for displaying danger, and green for displaying health or like poison. There was a great video that I watched on this that sort of breaks down these pillars in greater detail. I'm just going to do a brief overview of all of them, but I'll link that in the description as well. So moving over to shapes, starting with round objects. These sort of are inviting to the player, and they welcome the player towards it. Stuff that doesn't imply any danger of any sort. This doesn't mean that you can't use spheres for dangerous stuff, because some attacks can be like radius based and you want to indicate to the player that that area is in danger, but you would obviously implement color and all the other pillars to display that danger aspect. Moving over to sharp objects, triangulated objects. These imply danger to the player, stuff that you don't want to go near. These are sort of widely used for like projectiles, like for sharp edges. Anything that sort of has jagged edges, the player tends to want to stay away from them. Okay, so moving over to contrast. Contrast is used for indicating to the player that a spell is either weak or strong. If the contrast is quite low and dull, it shows that it doesn't really have much impact on the player. It doesn't really stand out very much. And if you had a high contrast, it shows that the spell is quite powerful, or it's either dangerous or it's something you want to draw the attention to. So if you really want to draw the player's attention to a specific object or a place on the map or anything like that, high contrast is a great way of doing that. So moving over to timing. Timing is super important for implementing visual effects, as you could have the perfect contrast, perfect shape, perfect color, but if it's not implemented at the right time or doesn't have the right amount of anticipation, then the effect will feel very lackluster and it won't have a great impact. Using different curves is very important, so different types of curves create different types of effects. Will give the effect a different type of feel. There are some great graphs to sort of visualize this as well. So for example, a rocket launcher would be very linear and just like sort of straight, as it shoots straight out and doesn't really have much build up. Another example would be an explosion. It would hit the ground quite fast and then it would build up using this type of curve. Using these graphs is a great way to sort of plan out the build up of your visual effects. I got these graph ideas from the video that I linked previously. It's a great video, I definitely recommend checking out. And also a great use of timing is having different speeds of the effect. So if the effect is slower than the human heartbeat, it tends to be quite inviting, as it doesn't really indicate any sort of panic. But if the effect is moving quicker than the human heartbeat, then it tends to imply that it's something that you don't really want to go near. So what I'll be explaining today is the visual effects graph. The visual effects graph is a node-based system within Unity used to create visual effects. Similar to like blueprints and like visual scripting, and like the shader graph, all them sort of like node-based systems that you see in different areas of game development. I think this is a great way to break down visual effects, because it's like it takes something that looks like so complicated and complex, and it allows you to visualize it a lot easier, which is what I found quite helpful when trying to learn it. The visual effects graph uses the high definition render pipeline provided by Unity, obviously to take advantage of its high definition rendering and allowing to produce a lot better looking effects than what URP would provide. The graphical capabilities of the visual effects graph are 10 times better than the particle system. It's quite a popular system to use when using Unity for just basic death effects and gun effects and random stuff like that. The massive difference between the two is that the visual effects graph uses the graphics card of the PC to create these effects and gives it a lot more leeway when it comes to how many particles you can produce. You can produce up to thousands and thousands of particles depending on how good your PC is. So it is an extremely powerful system, and if you are developing a big project for PC, it'll be a great way to improve the visuals of the game. But as I say, the particle system isn't bad. It's like it works, it does its job, and it has its uses, and I will still be using it. It's not like one's better than the other. They're both good in their own way. They're both used for different devices, different platforms, and they're both good in their own way. They both have their advantages and disadvantages. Okay, so let's zoom into the body of the graph now and explain what each section does. So the spawn section is used to determine when the particles are actually going to be spawned and how many of them are going to be spawned. And yeah, you can also change the rate at which they are spawned, so you can have a burst effect, or you can have a single particle spawn if you're looking to create one instant of an explosion or an orb or anything like that. So if we press spacebar on this section, we can choose what spawn we want to use. So here we have a periodic burst, a single burst, and a variable spawn rate, and constant spawn rate, which is what we have currently. This means that all the particles will just constantly spawn. But if we were to go to periodic burst, we can then set a delay, and we can, have more control over when they are spawned, for example in a burst. So yeah, that pretty much handles all of the spawning. Okay, so moving on to the initialize particle. So this actually controls how many particles can exist at once in this one effect. So you can change the capacity. So at the moment it is 32, but if I up the capacity, it allows for more particles to be on screen at once. But obviously at the moment these particles have a lifetime decay, so they will disappear over time. So that example doesn't really work, but as you can see over in the background with the orb, there is a lot of particles there that are allowed to be spawned. This also controls where the particles are going to be spawned. You can constrain them into a box shape, or you can constrain them into a sphere, just like in the background. And you can also change if they have a velocity to them. So you can add a random velocity component to it here, which will disperse the effect outwards in any direction, which you can determine here. So if I change the X value here, it will then shoot the particles out to the right. You can also set the lifetime of the particles here as well. So this is how long the particle will be on screen for until it disappears. I will show you an example of constraining the particles into a shape when I go through the effects in the background, or the effects that I have already made. I can show you how all that works. But for now, let's move on to the update particle. So the update particle is very similar to any sort of update function in programming. This is sort of where you want to be changing the size of the particle over time, or is there you can determine if their movement is going to be affected, stuff that you want to sort of happen every frame. So in here we could change the color over time, we could change the size, we can change all these different types of things, but it will just happen at a constant every frame. So the output particle, this is where you can change the look of the particle and what is inevitably going to be outputted onto the user's screen. You can determine what type of particle is going to be spawned. You can choose it to be a mesh, or a line, or a quad, or a decal, or any sort of sprite that you want to use. You can also determine what direction it is going to face. You can say, is it going to be facing the camera, or is it going to be just an effect that you can see from all angles and it stays the same from each angle, or do you want it to be constantly facing the screen, almost like a billboard? Here you can change the color over lifetime as well. So if I wanted to make the particle gradually turn red over time, I could do it here with the gradient. And you can also set the size over lifetime using the animation curve. This is very popular in the visual effects graph for different types of animation curves in many different examples. You can also use the shader graph with the visual effects graph as well. You can add a shader to add that final last little touch on how the particle is going to be outputted. So I really hope that is a decent overview of the graph. I'm going to move on to each individual effect that I have made and sort of go into a little bit more detail on how things are working. So I hope that was a decent explanation on how the visual effects graph is structured and what each section does. I'm going to go over all the different effects that I have made so far now and go into a little bit more detail. So I think I'm going to start with the spark effect. This was the first effect that I ever made using the visual effects graph. So I'll try and explain this as best as I can on what this is actually doing. So the spark rate is the rate in which the spark is going to be shooting out. So as you can see here, it changes in real time, so I can see what I'm affecting as I'm changing it. So if I increase this, it goes fast, and if I shoot it down, it then goes slow. Well, not slow, sorry, it just shoots out less sparks. So yeah, that's pretty much what that variable is doing. And if I change loop to false, it no longer loops. So what that is doing is saying if the loop is true, then you want to use this spark rate, and if not, then we're going to be using the single burst. So if I was to press play, for example, now on this effect, so if I go to this effect now and I press play, it would then just shoot the burst out once, so that means it's no longer looping. So that pretty much is how I've used the spawn section to create something like that. So let's try and break down the initialized particle section. So here we have the capacity as set to 39. If I was to increase this value, then I would be allowing more particles to spawn. So as it's on single burst right now, we can't really see what that is actually doing, but it would allow the particles to spawn. If I increase this value as well, there's more particles spawning. So yeah, up the value a little bit more so you can see it actually happening. So yeah, as you can see, that is a lot of particles, and I'm allowed to produce that many particles purely because I've increased the capacity. So if I was to lower this now to 2, it would produce 2 particles. So those two values work hand in hand. So moving down even further, we have a random velocity block, which is setting the velocity of the sparks randomly. We also have the position of the particles spawning from a sphere. So if I move this out a little bit, all it's really doing is just spawning the particles from inside this sphere. It's not shaping the particles in any sort of way, but it's just saying, you know, spawn from inside this sphere. And down here is where it gets a little bit more interesting. So we have a random number here on the y axis of gravity, and that's obviously pulling the particles down and hitting the collision with this box. So we have a fake box here that is acting as a collision for the sparks to bounce off of. We've also added a little bit of turbulence to add some more randomness. The turbulence block is great for making things look more realistic. It's almost like acts as like fake wind almost, so you can like make it look a little bit more realistic instead of just having a set value for the gravity and a set value for the velocity. Sometimes that random number isn't enough, and you need that little bit of extra turbulence. So yeah, it's perfect. A very good useful node to be using, or block. Okay, so moving on to set size over life. So all this is doing is using a curve to tell the particles to gradually get bigger and then get smaller as they come to the end of their life. So as you can see, they start off quite big, and then as they bounce and stay alive for longer, they slowly get smaller. So moving on to the next block, which is force. This basically says how much force we're going to be using. So if I increase this loads, you can see that the force is getting greater, and they go more in a straight line than they do fall. So yes, that's pretty much what the force node is doing. And you can determine where the force is actually applied. So if I increase the y-axis, they will fly up in the air, and so forth. Okay, so also you probably noticed that I have something here as well, but I'm currently not using this. This is basically a on trigger event for when the particle dies, and it goes into another event. So you can actually make another separate graph inside a graph. So you can have two different particles working hand in hand. So I will link the tutorial down below, which will also go into details on how that actually works. So if you watch the spark effect tutorial, he will go into detail on how that works as well. So moving on to the output particle. So in here we have the orientation of the particle. If you remember in the graph that we made, it was facing the camera, but if we go around this particle now, we can see that they don't move to face the camera. It just stays in world space, which is pretty useful. Obviously you would want some effects to face the camera, and you would want some to just be as they are, and they would just be an object that you can walk around and it doesn't change. And we also set the color over life as well. We can also create a gradient that would change their color over lifetime. So we have they start off bright orange, for example, and then they get whiter before they die. So yeah, I went over that pretty quick. So if you want to go into more detail on the spark effect, again, I will link the video in the description. Okay, so change of plan, because this video is getting quite long actually. So I'm going to go over one that I find quite useful, and then I'm going to go over the ground slash, and then I'm going to leave it at that. Okay, so moving on to one of my favorite effects, which is the orb effect. This orb is literally made up of 50,000 particles. Using this on a mobile device game or any low-end console or low-end PC would probably set it on fire, or any Oculus softwares or anything like that. But for a high-end PC game or high-performance PC games, this would work perfectly fine. So I'm not going to go over the whole graph for this effect, because it is very big, and it would take ages to go over when you could just go and watch the tutorial on how to make it. But I just wanted to show you that I've set the capacity to 100,000 and set the spawn rate to 50,000. Yeah, you can change how many particles you want floating around this orb. So pretty much I've just constrained them to a arc shape, so that's why it's constrained to sort of almost like a sphere. And I've also changed the way it moves using Perling curl noise. It's all goes into very in-depth on how it does this awesome effect, so I'll leave that video in the description also. Okay, so moving on to the smoke effect. This effect is pretty cool. It is using a flipbook technique, so it is using a bunch of images, almost like a sprite animation, to create the smoke effect. So in this graph we have the smoke and we have the fire. So we have separate particles here, as you can see, the little fire particles at the bottom, and we also have the smoke particles. So that's how the two different events can be used in one graph. Perfect example right there. So if we go into the smoke, this is the main bit that I wanted to share. So we have here the UV mode as flipbook blend, and we can add the color map and the normal map. So here we have the smoke sprite sheet, so we have loads of different images that make up this effect. And we've also added a normal map so that the lighting from the little fire at the bottom would react to the smoke correctly using this normal map. So yeah, that is also a pretty useful technique to use, and yet again that video will be linked in the description. Okay, so finally we have the ground slash. Now this one is probably my favorite one. So pretty much this is a actual effect that can be used in the game. So if I press play, I can show you this example. So here we are in the game view. If I go over here and I click onto the screen, the effect will happen right in front of me. So as you can see, the slash will go across the ground, shooting out loads of debris and leaving a trail on the floor. So this effect was my first time actually using keyboard input or any sort of input in order for the effect to be triggered. So how the decal actually works on the ground and how this whole effect actually works together. So if we go over to the graph again now, let's make it a little bit bigger. I can explain this and how it works. So if we go to the decal, first of all, this node here and this spawn over distance allows it to be used as almost like a force, and it almost like follows wherever the actual effect is placed. So if I was to move the effect around, for example, let's go to the scene, let's click on the ground slash. I actually have it in the scene right now. If I was to move this around, the effect would actually happen as I move the location of the effect. Decals have a different output as well, so you have to delete the initial output and drag off the update particle and create a decal output. Okay, so besides from the decal, we have the actual slash itself. So that's the actual shape of the slash. So if we go here and we press play on the event, you can see this thing here, the actual slash, the orange slash. I modeled that in Blender. So down here we have the actual link to the mesh. So we have the curve here and the actual mesh itself down here, and the texture, which is just a basic gradient. So for the actual effect to move and actually be triggered by a click event or anything like that, any sort of input, you actually have to make a script. I got this code from the tutorial that I followed. I'll link the channel in the description, as I've said about 1,000 times in this video, but everything will be on there explaining the code. But as you can see, we have the different variables that can be used here. So the speed of the effect, the slowdown rate, the distance from the ground, and the destroy delay. And we also have to add a rigid body to the effect in order for it to be affected by physics and actually be able to move. So yeah, that's a very brief breakdown of it. If you actually want to go in depth on how the actual code works, again, I think I've said this about 1,000 billion times. It's in the description. Okay then, so to conclude, we have gone over the Visual Effects Graph basics. I have explained each section in the Visual Effects Graph, and I have gone through each effect that I have made so far. I would recommend going from learning the very basics. If you want to go over everything again, go from the very basics, learn the structure in and out, learn what each block is available within each section, and then you want to go over to creating a still effect. What I mean by that is like something that can't be affected when you press play on the screen, and it's just going to be there when you press play. You can't affect it in any way. And then I would go over to trying to script these objects or effects, sorry, into actually moving when you press something on the keyboard and stuff like that. And if you have the money to spend on a Udemy course or any sort of course, I would definitely recommend doing so, because they give you access to their projects and you can take a deeper look on what they've actually done themselves. So yeah, hopefully you found this video useful. If you did, make sure to leave it a like and make sure to check out the description. I'm going to try and structure it best I can, all in order for you, and yeah, be sure to copy and paste all of the links and put it in a document somewhere if you want, save you coming back to the video over and over again. Yeah, so hopefully you enjoyed, and I'll see you in the next one. Thank you for watching.